So the first proof we have in this lesson says that given the quadrilateral ABCD, BC is congruent to DA, so I'm going to mark it. And BC is parallel to DA, so they already have this marked for us. We want to prove that AB and CD are also parallel. We don't know this yet, but we want to prove that. Now again, think back to the flow chart. If I want to prove that lines are parallel, I have to prove that angles are congruent, and because of that, I have to prove that triangles are congruent. So let's highlight my triangles. So I'm already given a side from the given. I can see that there is an overlapping side. So because there are two sides already given, I know that I have to look for an angle in between them. So I have to say that these two guys are going to be congruent. What is my reason? Well, if I look at these guys as my parallel lines, angles 1 and 2 are inside the parallel lines on opposite sides. So these are alternate interior. So I'll be able to say that angle 1 is congruent to angle 2 by alternate interior to get my triangles are congruent. Let's pause there and write this out. So write down your given. Now, the reflexive postulate I put on number 3, so AC is congruent to AC, so that's my, so I have one side here, one side here. I need to put the angle. The angles are angle 1 congruent to angle 2, and the reason we said is because alternate interior angles are congruent. Now, I can say that triangle ABC is congruent to triangle DCA by side angle side, congruent to side angle side. Now I want to look at AB and CD. The pair of angles that I want here is called 3 and 4. We can now say that angle 3 is congruent to angle 4 by CPCTC. And now my last statement is always the proof statement. So the reason here is because when alternate interior angles are congruent, lines are parallel. This is very similar to what we've been doing. As you can see, most of the time when we're dealing with triangles, you're going to need to state that alternate interior angles are congruent, most of the time. So now the next one, triangle ABC with angle CBA is congruent to angle BCA. Prove BA is congruent to CA. Now you can see this is a very short proof. We know that angle CBA is congruent to angle BCA. Now you can look at your cheat sheet and you can see that we can say that right away AB is congruent to AC because opposite sides of congruent angles inside a triangle are congruent. Because this is an isosceles triangle. Isosceles triangles have two congruent sides and two congruent base angles. So the next one has a property that we haven't really talked about that much. This is the transitive property. So briefly before we go into the proof, the transitive property basically says, so we have one more, okay. The transitive property basically says, right, that if we all agree that 5 plus 3 is equal to 7, right? We also know that 7 is equal to 4 plus 3. I'm lying. That is completely wrong. 5 plus 3 is equal to 8. 8 is also equal to 4 plus 4. So we would all agree that 5 plus 3 is also equal to 4 plus 4, because they're both equal to 8. It's basically saying that if A is equal to B and B is equal to C, then A and C are also the same. So with that in mind, let's look at our proof. We're given angle D is congruent to angle E. A is the midpoint of DB. You guys love using midpoint even when it's not there, so we can actually use it this time. So A is the midpoint of DB, so we have DA is congruent to AB. We know that B is the midpoint of AE, so B is the midpoint of this green piece. So I know these two are congruent. Now, if you look, there is an overlapping piece in the middle, but this time we're not going to use the transitive, the reflective, we're going to use the transitive, right? Because let's say that AD is equal to 5. Then AB would have been equal to 5. But if AB is equal to 5, then BE is equal to 5. So what can you say about AD and BE? You can say that they are the same. Now, we're looking at these triangles. So let's highlight that. So CDA and CB. So we're given the angle. We can say the side by transitive. We need one more thing. Well, in a triangle, so we have triangle CDE, we have two congruent angles down here, two congruent base angles. Base angles are in an isosceles triangle, so you know that there must be two congruent sides opposite the congruent angles. That will give us our final side. So first we write out our givens. I'm abbreviating for the sake of time. So sides opposite of congruent angles are congruent. So that was our third sides here, right? So we can say that CE is congruent to CD because they are opposite of the given base angles. So that's an angle, a side. Now, before I use the transitive property is used because I have already broken apart my segments by the midpoint. So I first have to use my definition of a midpoint to state my two congruent pieces. So I know that DA is congruent to BA, and I also know that BA is congruent to BE. Now, if you look, BA is in both of these statements. So I can basically cut out the middleman and say that DA is congruent to BE, and that gives me my final side. So I will say that triangle CDA is congruent to triangle CEB. Reason, side angle side, congruent side angle side. Given triangle ABC, CA is congruent to CB, AR is congruent to BS, DR is perpendicular, so these are right angles to AC, DS is perpendicular to BC. Prove the sides DR and DS are congruent. So let's go through and mark. CA is this entire side is congruent to CB. So these two are the same. AR, let's use a different color. So AR is this piece, is congruent to BS. DR is perpendicular to AC, so DR and AC form right angles, as does DS and BC. So I want to prove that DR and DS are the same. So if I'm looking at these sides, I want to be looking at these triangles. So I'm looking at this guy and this guy. So I want to prove that those sides are congruent using CP/CTC. So then I need to show that the triangles are congruent. Okay. Well, first let's write givens, because there's a lot. And then we'll look at the diagram and see what we can say. Now, because we have perpendicular lines, we're going to have two right angles. So we know that angle 1 is congruent to angle 2 because of perpendicular lines, right? So this is our angle. We're given a side with AR and BS. Now, why did they give us CA and CB? Let's look. So they gave us, no, I don't want to erase. They gave us, right, if we're looking at this triangle, if we look at the larger triangle, they gave us information about these two sides. If I have a triangle marked this way, I have two congruent sides. If I have two congruent sides, that is an isosceles triangle. An isosceles triangle has two congruent base angles. You can also say that opposite congruent sides are congruent angles. So these two angles right here are the base angles of the larger triangle. So angles 3 and 4 are congruent because they are opposite of congruent sides. Now I have angle, side, angle. And I can say that triangle DRA is congruent to triangle DSB. Finally, DR is congruent to DS.